Cities maintain lots of data. Raise your hand if you agree. Nice. On the right track so far. Civic technologists want that data because it can tell us a lot about what's going on in cities. I'm not going to make you raise your hand anymore. But I think we can all agree, too, that what is happening in a city is not as meaningful if we don't know where it's happening in a city. And this also applies to states and counties and countries and the whole lot. Fortunately, many of these city data sets have an address field. And this gets us part of the way there. If we have an address, we can do our manual magic to figure out where that address is associated with a place. But machines are not that great at understanding the nuances between different addresses and tying them to physical locations. That is a process that is called geocoding, which we'll talk about in a little bit. Oh, that got weird. But we want to make it easy for machines to match addresses to physical locations. And that's kind of the point of all of this is with government data, we can enable that. How? How can we do that? Well, there are some gentlemen here who will be happy to tell you. One way, which we'll hear about from Mike Migurski, is opening up parcel data. That's a good first step. For Ian, we'll talk about open data standards for addresses. Tom will talk about pulling addresses out of plain text. And Erik here will talk about building your own geocoder as one of the ways that you can do this. And ultimately, the thing that ties it all together is open data. Sort of a theme this conference. I don't know if y'all have picked up on it, but data, information, open access, that sort of thing. People seem to enjoy that. So without further ado, I'll let Mike kick it off and talk about parcels. I'm gonna run through these really fast and then you can remember what I said. See? Awesome. Great. Wonderful. Look, and now it doesn't look as bad as it looked on here. Oh my goodness, how? We can open parcel data. We can have open data standards and pull addresses from plain text. We can take a minute to look at Tom's photo there. And we can build a geocoder. So open data, awesome.
Hi everybody, my name is Michael Migurski. I know many of you. I'm the Chief Technology Officer at Code for America. Been in the position for about a year and a half, so this is now my second class of fellows that I'm working with. And I'm here to talk a little bit today about parcel information. Code for America is in the very early sort of exploratory research phases of looking at an open data standard for parcel information. We've done a lot of different open data standards in the past, connected to things like restaurant reviews, building code inspections, and trail data if you were in the open trails session in this room just about an hour ago. So parcels is sort of the next thing that we're thinking might be interesting to look at. And there's a bunch of different reasons why we think parcels are super interesting to pay attention to. But I'll be talking about kind of four aspects of parcels. One, what are they, for those of you who aren't familiar with parcels, or kind of why we might be interested in them. Two, why do we actually care? Why is this important to Code for America specifically to get interested in? Why it's a kind of difficult problem, and why a lot of the folks that we've talked to about parcels initially kind of warned us off of dealing with this issue. And then finally, what happens next in terms of Code for America's involvement in this. So first off, what's a parcel? A parcel, actually, maybe a small show of hands for anybody who doesn't just intrinsically know what a city parcel is. Lyzi has no idea. Awesome. A parcel is a small tract of land. They typically look like this. And they're used by cities, municipalities, everybody else in order to interface with the citizens who typically live on or own or deal with the parcels in some way. There's all kinds of city functions that connect to parcels in intrinsic ways. The one that we're thinking about, because it tends to be the kind of most common that a lot of regions do, is county tax assessor information. But there's also a lot of other city functions that interface with parcels. Water gets delivered to a parcel, electricity gets delivered to a parcel. There's all kinds of basic core services that kind of intersect at the parcel. It's kind of the joint between citizens and the government above them. And so it actually ends up being really important because we keep bumping into these data sets basically in almost any project that we do that has any kind of spatial component attached to it. Why do we care? I've heard it said as recently as yesterday that most government kind of boils down to land management in some form. This is typically an argument that comes out of GIS communities. GIS people often say that, if you really get down to it, a lot of open government data tends to just be spatial or location-based in some form. So most government is land management. Most government is about dealing with, what you do with this chunk of land or that chunk of land. And parcels happen to be the type of chunk of land that a citizen can own and can interface with the government. Parcels also help with economic development. If you remember Jen Palka's talk yesterday introducing the conference, she mentioned Code for America's 3 forthcoming focus areas that we're looking at. That was health, safety and justice, and economic development. Economic development happens to be one that's very tightly connected to parcels because there's a lot of sort of economic development relevant information that comes through via parcels. Just to give one example from in this room is Joel Mahoney's company, OpenCounter. This is something that came out of the 2012 fellowship at Code for America, working with the city of Santa Cruz, and has now been spun off into its own company via our, I believe, accelerator program. OpenCounter is a system for looking at, places to put a business. It's interested in things like zoning regulations and where you might be able to put one or another kind of a business. And it just so happens that parcels are typically the way that cities and counties actually encode all this information. So there's all kinds of very, very granular, very, very useful and directly interesting kind of economic development related information that comes through with these parcel layers. So it's pretty interesting to us because it touches very, very heavily on this core focus area that Code for America has chosen to kind of throw its hat in the ring of over the next couple of years. There's a lot of challenges associated with parcel information. Just to name a few, there's the consistency of data sets, there's availability of data sets, and there's cost recovery associated with data sets. So, I spoke with Mark Head, for example, a couple of days ago. He used to be chief data officer of the city of Philadelphia, and I was telling him a little bit about this effort, and he sort of mentioned offhand that Philadelphia had something like 6 different competing parcel data sets that were stored by different elements of the city. You had the water people had kind of their view of the world. You had the GIS people had a different view of the world. And so there's a massive problem around consistency. Obviously, a data standard isn't necessarily going to solve consistency, but it helps to kind of flush consistency out in the open and helps make it kind of a subject of discussion rather than just kind of a dirty secret. Availability and cost recovery are fairly closely linked with parcel data. If you're familiar at all with California open data politics, you've probably heard about 2 lawsuits that were brought against, I believe, Santa Clara County and I want to say Orange County over the past couple of years. These were lawsuits that were basically brought by different parties that were interested in using parcel data out in the open. I believe in both cases the counties lost the lawsuits and were forced to open up their county parcel data. But in both cases they were sort of cooperative only to the point of releasing the parcel numbers, the APNs, and the actual geometries of those parcels. There's a lot of other stuff connected to parcels that can be enormously useful if you want to do economic development type things or addressing or geocoding or whatever. All kinds of attributes that hang off of these things that have to be sort of, in many cases, sort of lawsuited out of certain governments. For the most part, California counties and a lot of counties are, largely happy to part with this stuff. It's a very useful type of data set. I remember speaking with Laren Dalby, who used to be GIO of the state of Arkansas, and his whole approach towards dealing with the counties under his jurisdiction and open data in the state of Arkansas was essentially to say, nobody cares about Arkansas and the rest of the country. And so when we get hit by the projected giant earthquake that's supposed to come to this part of the world sometime in the next few decades, when we start getting into that place of needing to deal with, disaster recovery and finding victims of this thing, or when we're trying to court car companies to open up factories in our state, basically our approach is just push the data out as aggressively as humanly possible. I met Laren at the first State of the Map conference, which is dedicated to the OpenStreetMap project, and he was there basically as a state representative saying like, hey, open data people, how can I push this onto you so that we can get as much of this data and as much of these roads and parcels and things out in the open as humanly possible. So Laren really kind of articulated for me the sort of when push comes to shove rationale of open data, the idea that when you get into these like tight economic or disaster spots, you really want to have stuff like this out in the open so that it's directly available to you. Code for America has sort of a set of methodologies around how we do standards that we're hoping to bring to bear on parcels in particular. This has sort of come out of our work, especially most recently with Open Trails, working with Alan Williams sitting there in the back, but also with the lives and house fact standards that I mentioned around restaurants and building codes. First of all, it's really important to think about the people, the needs of end users, as opposed to just the data. So it's not so much just a kind of, drumming shapefiles or Excel spreadsheets out into the wild kind of exercise, as it is figuring out what those direct needs are. And that's where the kind of economic development focus area comes into play. It's about working with governments and understanding what the human and technology infrastructure is there. So in a lot of the standards that we've worked with, we've seen how things like Open 301 have been very difficult for governments to adopt because it's a very sort of, techie, nerdy kind of XML, RDF type standards process. We're looking for things that are much, much easier and based on technologies like, comma separated values, spreadsheets, GeoJSON, other sort of technological choices that should make it as easy as possible for people who aren't developers in cities to be able to participate in these efforts. We don't like picking winners. We're interested in supporting an ecosystem of this stuff. So working with companies, working with governments, and working with communities that can all kind of come together and work on these standards together. And then finally, the don't pick at it principle, which is to not do continuous revisions of standards, but to very early kind of approach something that feels like a 1.0 for a lot of people, and then just leave it the heck alone for like a year so that people can kind of get accustomed to it. Again, one of the lessons of Open 301 that we found is that for standards that are continuously evolving, we've found that a lot of city partners basically just go hands off and ignore them until they perceive that the thing has stopped moving. So we're committed to the idea of working on this in such a way that there could be some sort of 1.0 point in the future where we can just sort of put it down and say, okay, it's done for now. Everybody have at it. So next moves, we're looking at doing research into this subject area, and we're looking at something like a descriptive format. So if you can imagine a prescriptive format is us telling people how they should release parcel data, that doesn't make any sense because there's obviously a lot of systems and companies and kind of installed bases of GIS folks out there in the world that are doing this stuff. So we're looking at approaching it from a more descriptive angle and basically performing research to see what's out there. What counties and cities make this stuff available? What formats do they make it available in? What kind of columns are there? And can we somehow categorize these, different groups of columns into things like zoning or addresses or identifying numbers or linkages or concordances to other data sets? So if you're interested in helping or communicating or participating, that's my email. I'm mike@codeforamerica.org. I'm also Michael Migurski on Twitter. And I'll be around at the conference for the remainder. So please come find me and please come talk. Thank you so much. And now, Ian Dees.
So I started off a long, long time ago doing OpenStreetMap stuff. For those of you that don't know what OpenStreetMap is, OpenStreetMap is the Wikipedia of maps that anybody can edit and improve the map. Using their own local data. And one of the greatest things about living in the United States is that the government has released quite a bit of information. And way back when, I was trying to get all that information into OpenStreetMap. And people in OpenStreetMap didn't like that very much because it tends to pollute the data set. The process of importing data into OpenStreetMap is rather tedious, and there's a lot of people that have a lot of opinions on how that should happen. So what I ended up doing was saying, thanks guys, but I'm going to go do my own thing. And I created this thing called Open Addresses. This is really trippy. Okay, so Open Addresses started off as a Google spreadsheet where each row was a data set from some municipality somewhere, mostly in the United States because that was the most prevalent data set, but we are looking for data throughout the world. And it was mostly links to shapefile downloads and Esri REST endpoints. And the goal was to create just a list of data that I could maybe at one point in the future convince OpenStreetMap to import. And as I got bored with it, actually, what was actually happening was I was running out of new data sets to add to that spreadsheet. Somebody convinced me to move it over to GitHub, and so now we have this open addresses group organization, and each row in that spreadsheet is now a JSON file in this repo. There's 650 or so lines, and each of these is a source of data of some sort. So most of these are Esri endpoints. Some of them are shapefiles. Some of them are Parcel datasets. Some of them are addresses. And the goal here was to simply collect all that information. Each one of these files has information about what area it covers. Mike over there went and added some information about what U.S. Census jurisdiction it covers. And then there's this data link here, which points off to, in this case, a Esri endpoint. Will it work? Look at that. Dang it. Yeah, so in this case, you can see it's pointing to this layer here, and then there's a script that will go and grab all this data in as nice a way as possible, basically scraping their Esri endpoint to create a GeoJSON file. And so for all 650 or so of these sources, we go and download the data, convert it, and then spit out a nicely formatted CSV file. Addresses.io. Wow, I typed that without looking. I'm so grown up. So the list, the aggregate list, is a gigantic CSV file with latitude, longitude, and a address. And somebody at Mapbox made a map, and this is what the data points look like right now. And some of the data set that we have isn't even on here because we haven't gotten to the point where we're doing the some of the mapping between the source data set and a latitude, longitude correctly. But you can see things like we have all of Vermont, we have most of Idaho, or maybe that was Utah. But the point here is that we're taking all this this parcel and address information from local municipalities and making it more globally useful. We are losing some information, but it's at least it's there and indexable. So one of the things that, and the reason I'm at this talk is I'd like to try and figure out how to make this more, include the ability to have parcels in here more explicitly. So let's see if I can remember how many backs I need to hit here. Oh, I made a new tab. So one of the data sources that we find a lot is parcels, and parcels tend to have the site address on them. And so in that case, this download script tends to download the parcels and then get the centroid, the middle point of the parcel. And it does that all transparently right now. But my hope is that we can use this same sort of process to more explicitly call out parcel data and make an index of parcel data to flow into Mike's parcel nomenclature, I guess would be a good way to put it. So what I would love to have you guys all do is do a search for, when you get home, do a search for your local area's GIS data set and look for address or parcel information, however you can find it. Most of this data was me searching for X county GIS and then poking through their website if they have one and creating a new file in here as a pull request and hitting send. And so actually I think, I don't know if we canceled that or if it's over yet, but the folks at Open Data Institute, let's see if it's up here at the top. Yep. The folks at the U.S. Open Data Institute are offering a bounty So they have a bunch of money that they're giving us. If you guys want to earn $10, find your local data and throw it in as a pull request, and you get $10 in a month or so. But so that might sound kind of silly, but for me, at least when I did that Google search, I found maybe 50 data sets, and I did that in a weekend. So that's not actually very little money. It's it can balloon and be worth it. So like I said, the goal here was originally to find address data to make OpenStreetMap better, but it became so hard to improve OpenStreetMap that I just indexed it separately. I'm looking forward to making it more parcelable, more friendly to parcels, and I encourage you guys to try and use it yourself. I guess that's it. Thank you. I forget who's next. Tom.
Well, yeah. Well, thank you, Ian. We used Ian's census reporter to figure out some stuff for I'm a Fellow this year in Mesa, Arizona, and we used his census reporter to kind of figure out some stuff that we need to know about the bounding areas of our city and things like that. So Ian's done lots of interesting work, and I encourage you to check out his GitHub repo and contribute your addresses if you have any. So we had this problem in Mesa where we were working with a whole bunch of legislative data, and basically like just blobs of government text data, and we needed to identify addresses. Or actually, sorry, more specifically, we needed to just kind of parse out a lot of this text to make it more relevant to users, because it's pretty hard to read, and we wanted to present it to people in a way that was engaging. So the first thing we thought of was, well, maybe addresses and roads would be something we could pull out and then allow the user to kind of enter into this text or into this legislation that was going to happen near them through that geographic information first. So our site, you put in an address, and then it pulls up legislation that's near you. We had a hard time figuring out how to actually parse out and find the bits of text that were referred to things like roads and addresses. There are sort of, I was reminded of some people who have solved this problem. Metacarta has a full text geocoder. I'm not sure they even really exist, or they were acquired, I think. And so I couldn't find an endpoint for that. There's an EB data Python package for doing this, which was part of EveryBlock. Does anybody remember EveryBlock? And they have an address discovery tool in big pieces of text, but it was this really long Baroque regular expression. Has anybody seen like a regular expression that's just like 300, 400 lines long? So we just didn't really we didn't really want to kind of do that, or we couldn't figure out how to use that. Also, it identified addresses and not roads. So we wrote like a little thing that solved this problem. The problem was to find geographic elements in text. This is kind of the classic way a full text geocoder would work. Somewhat in some ways, some of these things are kind of convoluted, but basically, find the elements, parse them, get the locations, and return and display the location somehow to the user. So we mainly focused on just finding the elements, getting the footprint, and returning and displaying the footprint. We did this using, we used road names, basically, and I looked in the academic literature. What we did is actually, we wrote, we sort of made a gazetteer, which is actually less a geocoder, but more a gazetteer. I don't think the names really matter, but basically, we send off address-like text to a real geocoder, and I'll tell you in a second about how we kind of just walked through to find this text. We pulled Tiger data, which some people are probably familiar with Tiger data, and it was actually, Erik had the brilliant idea that for a restricted set of roads, you could just, or features, you could use that restricted set to search against with the blobs of text from legislative data. And then we just sort of basically walked through that text, and where we found a suffix that we thought was a potential match for a geographic element, we would walk back through the text and until we found the matches in the database for that text string search were equal to 1, and then return those elements. There are a lot of interesting things to do potentially with this kind of text parsing. They're very difficult. So it could be difficult. It could be easy. So for example, the idea of if you had in text someone said, this contract is happening on South Dobson Road between Broadway Road and Dobson Road. You could do things like, assuming in Mesa perpendicular streets, you could draw a line between those streets, between the intersections of the points of the lines, and you would have basically the area of interest for that particular piece of legislation. We do have like a little thing up on the Code for America GitHub. It's called Lil Geocoder. You can just kind of plop text in on the left of the screen, and it'll parse it and return the elements that it thinks are roads for a given area. We'd like to make this generic so that you could just do it for basically any little area with Tiger data in the US. And we think that should be fairly easy. So if any of you are interested in doing full text search, or you have a whole bunch of text that you would like to find geographic elements in your city, please talk to us.
Okay, so yeah, I'm a fellow this year in Lexington, Kentucky, and a lot of our work has just ended up surrounding geographic information, and we're sort of working on neighborhood quality of life, and we ended up with a ton of data sets that related to place, and so we found ourselves geocoding things over and over again, and so we just ended up sort of playing with different ways to get to accomplish that goal, and one of the things we ended up doing was doing our sort of using a really nice open Parcel data file that the city maintains in order to create our own geocoder. And we were just sort of surprised at how useful it ended up being. So so I'll talk a little bit about that here. So that, because we had all this information that we really wanted to be able to tie to the place, we ended up going down this road. So this was our sort of a bit of our problem, is that we had all of these different address-oriented data sets, and we wanted to be able to connect them in some way, because we're trying to get a picture of neighborhood quality of life. It's obviously a complicated thing, and to be able to do this effectively, I think you need to be able to have a vision across these data sets in a way that most data work. You're able to connect these different data sets in joins and things like that, and so we wanted to be able to find a way to do that. So this is it. Yeah, it was basically trying to, because we had this nice parcel file, we were able to sort of assign all of these addresses back to an actual unique parcel in the city, and it felt like we started to approach something that was pretty useful to get us to that goal. So this gives, I think people probably have a decent sense of this, but this is a humorous approach to like the problem. This is one data set and the address is spelled this way. This is a different data set. The address is spelled this way. So, if someone's like going out to this place, you hope that they can get the entire thing. If they don't, bad things could potentially happen. In this case, they'll see that they're actually the same parcel. So they'll bring a net and be able to capture the snake potentially, or hopefully all of the snakes if they're good at it. And what we sort of found when we were talking with the folks in the city is that there were different people out there who were doing this work, and they were, approaching this problem essentially, and they were pretty effectively able to do it in some cases, but they're all kind of like doing their own thing in their own different departments, wherever they are, doing their analysis, and that's great, except you don't, I guess the way that breaks down is that, some of them did it better than others, and then they weren't able to learn from each other, and then they all sort of were reinventing the wheel and using their own process. So we thought this is kind of a cool thing that it's just like in this vein of systematizing things. Obviously, it gives you a central place to focus your efforts, so that as we started this process, we knew we needed feedback to make sure that our geocoder was not just completely off the wall doing weird things. And so now we have a system where we focus that effort, and we can sort of look at other geocoders and compare our results, and sort of over time start to incrementally improve the quality of the service. We were a little bit intimidated by it, and I think, like I said, we had a few things that I think were in our favor. We had really nice parcel information to begin with, and I'll speak to the next bit, I think, here maybe I think part of what made this useful was that you're not trying to geocode, you're not trying to solve the problem generally. I think that is obviously an incredibly difficult problem. some of the what made this service useful is that we're just talking about a locality that has its own quirks, but you're also the problem area is just so much smaller. And this is definitely what we found. As we just talked with different people in the city and we started to roll this out, there were lots of people that were excited about this. They said, they just felt like they've had the siloed data for ever and ever, and with this simple approach, they were able to bring that together. So what we did, we grabbed the city parcel file and we basically dropped it into, created a database with that, and ultimately used, I think, Elasticsearch. I started dropping out here. So our parcel file had, and it actually, to be honest, we don't actually need the parcel information necessarily. I think sort of like Ian's talking about, in some ways you can just think about it as being like a canonical set of addresses, and then from there you can have coordinates, and then for us the bonus was that we had the boundaries, so you actually start to think about the geography, the actual boundaries of the parcels. So obviously you can do even more with that, and so in our case we were lucky to have that information too. And then I think this is where we started to take advantage of the amazing work that's out there already. Obviously, Elasticsearch, if people have used that type of product, it's just does a really good job of sort of understanding what text is all about. And so without doing a whole lot of work, we were able to get something that understood the nuances of addresses pretty well, and then basically make this service something that was pretty useful without a ton of work. So in the future, we are looking at basically creating feedback mechanisms for this to be able to sanity check it and to improve it and to tweak. There's something like Elasticsearch has many different levers that you can pull to make it more effective. And so we'll in the future we'll start to do that sort of thing. And that's basically our approach. I think that was the end. Yeah, this is what we found, and we're the project is already pretty useful, and we're continuing to work with it. So we're excited to make it even a more useful service for the city in the future. And I think that it's something that people in the city in cities, it's worth thinking about this sort of thing, because you can. You don't even necessarily have to stand it up as a service. If you're sitting there finding yourself having to geocode things over and over again, you can even just stand this up on your development machine and be able to like really quickly geocode things. You take away from the sort of systematized aspect of it then, but even still, you're able to geocode things really quickly and cheaply.
So when we were, boxing you in. When we were yesterday at the Civic Tech Fair, I was demoing our version of the geocoder, which is called StreetScope, and I'll be talking about it on the main stage later today. But I started to talk to people from different cities, and they mentioned their own nuances with addresses in their cities. Like in Dallas, for example, if you have Dogwood, some databases have Dog Space Wood, and some have Dogwood. And that's a common one. So as we start to learn more about different address nuances in Lexington specifically, we can pull those Elasticsearch levers. But the way that it exists right now, and you can play with it, it's streetscope.net. It's with absolutely zero customization. Like we haven't, it's just Elasticsearch straight out of the box. So we haven't done any customization on it. And it's like still pretty awesome, even without pulling any of those levers. So that's pretty cool. This is all of our contact information. You can talk to us if you want. We like it. And immediately following this, there is an unconference session called, you have the title in a text message. Using maps for civic dialogue, and that's in the ballroom right after this. So we have 10 minutes or something, but if you'd like to continue the discussion about maps and addresses and parcels, that would be the place to do it. Are there any questions for anybody? Yes. Well, yeah, it's not necessarily creating a centralized data set. Everyone still gets to maintain the data the way that they maintain it. It's more about adding an additional key to be a foreign key between them. So the ultimate decision is that the Parcel data set is the canonical address data set. And that's one of the cooler things I think about the geocoder is that it started that conversation in Lexington about how do we keep address data, who should decide how we keep it, how do we keep parcel numbers and that kind of thing, which is awesome because more people that are talking to each other, the more decisions get made that everyone agrees with. So we'll start back.
You mean like the actual like landowners of the parcels? We have not, interestingly. We did a project with parcels recently in the city of Oakland called Soft Story, which is available at softstory.codeforamerica.org. And the thing we were looking at there, this is actually like something that we felt maybe would like kind of poke at this particular hornet's nest, but doesn't seem to have so far. Oakland has a lot of buildings that are what's called soft story buildings or potential soft story buildings, which basically refers to like apartment complexes that have a big open parking area or open business area on the ground floor. And if these things haven't been, appropriately earthquake retrofitted, they tend to sort of pancake when an earthquake happens. So one of our former fellows, Dave Garino, did a mapping with the city of Oakland and the Association of Bay Area Governments to look at what all the potential soft story buildings and parcels were in Oakland and put all of this stuff on a map. And it started to kind of, poke a little bit at that kind of issue of the disproportionate number of poor people that live in these buildings and kind of economically what might happen there. But I haven't yet seen an outcry from landowners in particular. And it's been on, several local news stations and a few, newspapers and so forth. So I think I would have expected that to lead to a little bit of kind of crying, but I just haven't seen it yet. I mean, it's always been public data. I think what we're really talking about is like kind of wholesale rather than retail for this stuff.
This isn't working. There it goes. One aspect of parcel data that's kind of contentious and leads to some dispute about who owns parcel data is that it usually includes really personally identifiable information like tax and mailing address. And also, sometimes it includes like value and tax information that maybe property owners don't want to be public. And so I know that, for example, in Chicago, I think there was some hair raising about making that data available, at least at the whole county level. And so that's another thing to think about. There is there are some interests in not having that be public, and so you're kind of it's a lot different than just a plain old address, for example.
And I'll also say, as the parcel data standard starts to come to fruition, it will be interesting to see the conversation around what is included and what isn't in that data set. In terms of the geocoder, there's only 3 fields. It's parcel ID, well, I guess 4. Parcel ID, latitude, longitude, address. So none of the personally identifiable stuff is necessary. Go behind and then forward.
I think the closest we've seen to collaborative work has been largely in kind of outside of government organizations like OpenStreetMap.org. I think it's been fairly instructive to look at how governments tend to want to interface with OpenStreetMap. So folks like Laren Dalby from Arkansas, people from the city of New York, other folks that I've talked to, typically the way that they're interested in interfacing with these kind of open, broader communities is to use them as a signal of where change is happening rather than taking their input directly. So in New York, for example, I believe the people at Mapbox built a sort of, custom news feed that basically every day emailed people in New York to tell them that some street or building had changed within the city limits. And the people within the city weren't taking this data directly out of OpenStreetMap, but they were instead using it as a sort of signal to say, okay, something is changing there. We'd better prioritize this area for a new survey. So the government itself was still doing the survey and kind of creating the data and stamping it with the seal of approval, but was using this external input to help it gauge where it should focus its attention. So it's kind of more of a focusing kind of thing. As far as I think your first question was more about how do you kind of arrive at a single thing? I think this is where that sort of politics data boundary starts to get breached a little bit. And I think, when we talk about data standards, they have a way of sort of flushing those kind of disagreements out in the open. And it becomes a lot more kind of easy to talk about them when you can see that there's two data files versus two hidden things behind department doors someplace. So it becomes easier to have the political discussion, or at least to know that you have to have the political discussion, but it's still basically a who's in charge and who consumes whose data kind of question.
The 5 directors of different departments say they want to do this.
Mm-hmm.
They're all on board, the mayor's on board. What is the text? What is the database? Do we just dump it into a SQL database? And then how do they interface with that, I guess?
Right. Yeah, good question. I don't know if there's one answer to this. I mean, the idea that there would be one database is probably the one critical decision that has to be made. And then the actual identity of that database is it's Rhode Island, right? So it could be an Excel spreadsheet. I don't know. Sorry.
I have a question around OpenStreetMaps, actually. So I work for the Downtown Development Authority, City of Grand Rapids, Michigan, and we're building some digital tools that we'd rather use Mapbox or OpenStreetMaps than Google Maps.
Mm-hmm.
But our OpenStreetMap community isn't that big. Are there, so I was hearing about the issues, and I explored it a bit around how hard it is to import data into OpenStreetMaps. Is there any good strategy around the kinds of data sets the OpenStreetMap community would want from the government, or is it just simply encouraging a much more active OpenStreetMap community in our city to make those layers more relevant or better?
Yeah, Ian, do you want to answer this one?
Sure.
Right.
Basically, if you're trying to add data to OpenStreetMap, I would suggest signing up for the imports mailing list, which is kind of a crazy thing to suggest, but that's it used to be a really negative place, but now it's gotten a lot better, mostly because I don't let the negative stuff through the moderator queue. But so that's a good spot to start. There's also a really good wiki page on the OSM wiki, and I think the more important thing is to try and generate a community of people interested in this kind of stuff, whether it be from within government or outside, and sit them all down in one place and get them to start mapping and drink beers together and that kind of stuff. And pretend like you don't have any data to import, and kind of build up a community of people that are mapping and make them interested in that. And once you have that group of people that are excited about the map in your area, then you can start using your data as kind of a backdrop and bringing it in piecemeal. I've done both. I've done Chicago myself, and it was I imported all of Chicago's buildings, and I did it all by myself, and it was not very fun. And then there's also New York, which is kind of the opposite case, where they tried to build up a community around the process of importing data, and that didn't really work because importing really sucks. And so you want to attract people to the exciting part of mapping, which is like when it's blank and they get to create their own data, and then improve it later with the data that the city has. That's my thinking anyway.
In terms of building community around mapping, there is an organization called MapTime Map time groups are hands-on, beginner-focused meetup groups for learning about maps and geospatial. We have 40 chapters around the world now, and new cities we want all the time. It's kind of like knitting circles, but for making maps. And that's a great way to get people excited about OpenStreetMap. Also, if any of you run brigades, this year at Code Across and National Day of Civic Hacking in Lexington, we had groups working on editing OpenStreetMap. If you are like coming into the community not as a developer, it's a really awesome way to get involved in the open data and feel like you're a part of the brigade even if you don't write code. So that's another great way to get community around that. Oh yeah, maptime.io if you're interested in maptime. Shameless plugs. I think we have to. She yelled at me with her hand. Yeah, okay, done. But 11 o'clock ballroom, more discussion around parcels and addresses. Thanks.